students, very good morning. Myself Retulsa from New LGIT Institute of Engineering and Technology. Today we are going to discuss the subject Mathematics-1 with the chapter partial derivative. And in this chapter we are going to discuss the topic that is the examples of higher order partial derivative. So let's start the example. Our given question is if u equal to 1 minus 2xy plus y square raised to minus 1/2, then show that x del u by del x minus y del u by del y is equal to u cube y square. Okay, so let's start the solution. Here our given function u is 1 minus 2xy plus y square raised to minus 1/2. So the differentiation of u partially with respect to x, that is del u by del x, is equal to minus 1/2 1 minus 2xy plus y square raised to minus 3/2, and after applying the chain rule I have minus 2y. After simplification, this minus 2 and minus 1/2 that will be cancelled out, so the remaining term is y 1 minus 2xy plus y square raised to minus 3/2. This is equation 1. Now differentiating u partially with respect to y, that is del u by del y minus 1/2 1 minus 2xy plus y square raised to minus 3/2, and here minus 2x plus 2y. Okay, so if I get minus 2 common from this last bracket, and this minus 2 and minus 1/2 will be cancelled out, and the term is x minus y 1 minus 2xy plus y square raised to minus 3/2. This is my equation 2. Okay, now I am going to substitute the value of equation 1 and equation 2 in this left hand side term. So substituting value in value of equation 1 and 2, x del u by del x minus y del u by del y, right? So x, keep it same. The value of del u by del x, that is y 1 and in this bracket, right? So here y 1 minus 2xy plus y square raised to minus 3/2. Similarly, here y, keep it same, and the value of del u by del y, that is x minus y 1 minus 2xy plus y square raised to minus 3/2. So after simplification, this is xy 1 minus 2xy plus y square raised to minus 3/2. This is minus xy into the bracket, that is 1 minus 2xy plus y square raised to minus 3/2. This one is minus minus plus y square 1 minus 2xy plus y square raised to minus 3/2. Here first and second term will be cancelled out, so the remaining term is y square 1 minus 2xy plus y square raised to minus 3/2. So if I keep this bracket as 1 minus 2xy plus y square raised to minus 1/2 raised to 3. So both will be same, and this bracket is known as u. So my answer is y square into u cube. Okay, so this is what we want to prove. So let's move with one more example, that is if u equal to log 10x plus 10y plus 10z, then show that Sine 2x into del u by del x plus sine 2y into del u by del y plus sine 2z into del u by del z is equal to 2. So let's start the solution. Here our given function u is log 10x plus 10y plus 10z. So let's start the differentiation of u with respect to x first. So I have del u by del x, that is 1 upon 10x plus 10y plus 10z, and after applying the chain rule I have the derivative of 10x, that is sec square x. Similarly, for the differentiation with respect to y and z, that is del u by del y, here 1 upon 10x plus 10y plus 10z after applying the chain rule, this is sec square y, and with respect to z, it is 1 upon 10x plus 10y plus 10z. After applying the chain rule, the derivative of 10z, that is sec square z. So students, now I am going to substitute the value of del u by del x, del u by del y and del u by del z in the left hand side of equation, and that is sine 2x del u by del x plus sine 2y del u by del y and sine 2z del u by del z. So as you all know, the denominator of all these three terms are same, that is 10x plus 10y plus 10z. So if we keep as the common denominator, that is 10x plus 10y plus 10z, and the value of sine 2x, that is 2 sin x cos x, del u by del x, that is sec square x, here 2 sin y cos y, this one is sec square y, and the same for the last term, that is 2 sin z cos z, and this one is sec square z. As you all know, 2 sin x cos x, and the sec square is 1 upon cos square x. Same 2 sin y cos y, sec square y is 1 upon cos square y, and 2 sin z cos z, and sec square z is 1 upon cos square z, and the whole divided by 10x plus 10y plus 10z. Okay, so here 1 cos x will be cancelled out, 1 cos y, and same 1 cos z. So the remaining term is sin x upon cos x, that is 2 tan x. Here 2 tan y, and the last one is 2 tan z upon tan x plus tan y plus tan z. So if I keep 2 common, then 2, and the remaining bracket is tan x plus tan y plus tan z, and the same in the denominator, that is tan x plus tan y plus tan z. So the both will be cancelled out, and our answer is 2, which we want to prove. See, we want to prove this one is equal to 2. So here we have starting with the left hand side, and this one is the right hand side. Okay, so this is the answer of the given question, or we can say this is the proof of the given question. So let's move with one more example, that if u equal to e raised to x y z, show that del cube u upon del x, del y, del z is equal to 1 plus 3xyz plus x square plus y square, x square into y square into z square into e raised to x, y, z. Okay, so let's start the solution. Here our given function u is e raised to x, y, z. Okay, and as we want to find the value of del cube u upon del x, del y, del z, so either we go from right to left or left to right. So now I am going to left to right. So I am going to first the partial differentiation with respect to z. So the differentiation of u partially with respect to z first, right? So del u by del z, and here the derivative of e raised to xyz is e raised to xyz, and the chain rule, that is into xy. Now we are going to differentiation with respect to y. Del u by del z partially with respect to y. So del by del y of del u by del z, that is del square u upon del y del z, and this is del by del y of e raised to xyz into xy. Okay, so here 2 times y, so we are going to apply the multiplication rule. So the derivative of this xy with respect to y is just x. At that time e raised to xyz keep it same, plus the xy remains same, and the derivative of e raised to xyz, that is e raised to xyz with respect to y, so that is xz. Okay, so after simplification, this is, if I keep e raised to xyz common, then e raised to xyz, and in the bracket x plus x square y z, right? Now I am going to the partial derivative with respect to z. Okay, so differentiating del square u upon del y del z with respect to x. So del by del x, here del square u upon del y del z, that is del cube u upon del x del y del z, and this one is del by del x, and the value of del square u upon del y del z, that is e raised to xyz, x plus x square yz is e raised to xyz in the bracket x plus x square yz. Okay, so again I am going to apply the multiplication rule, and that is here e raised to xyz keep it same, and the derivative of this bracket with respect to x, that is 1 plus 2xyz, right? Plus this bracket keep it same, x plus x square yz, and the derivative of this e raised to xyz is e raised to xyz into yz. Okay, so if I keep this e raised to xyz common, then the remaining bracket is 1 plus 2xyz plus x into yz, that is xyz, and the x square yz into yz, that is x square y square z square. So here e raised to xyz, this is 1, 2xyz plus 1xyz, this one is 3xyz, and here x square y square z square. So this is the proof. This one is del cube u upon del x del y del z, and this is what we want to prove. See, del cube u del x del y del z is equal to 1 plus 3xyz plus x square y square z square into e raised to xyz. This is here. Okay, so this is the solution. Okay, so let's move with one more example. So this is the solution of the given example. Feel free to contact me for any query. Till then, enjoy the study. Thank you.